Let's say that I'm just sitting on the surface of the earth. Maybe that's me right over there. You can barely see me. I'll enlarge a little bit. Hanging out in northwest Africa. Maybe I'm hanging out in Morocco. And we know that the earth is pulling down on me, that the force of gravity from the mass that we call the earth is pulling me towards its center of mass, pulling me towards the center of the earth. And if we were to zoom in on things, if this is the ground, and we know that this is really just the surface of earth, and if this is me right over here hanging out, we know that there's a force of gravity acting downwards on me towards the center of the earth. And let's say that that force is 700 newtons. Now my question to you is, am I pulling we know the earth is pulling on me. This is the force of gravity pulling me downwards. But do I also pull on the earth? Is there also a corresponding force that I am pulling on the earth? And if there is a corresponding force, is it smaller than the force of what earth is pulling on me? Or is it the same? Or is it even larger than the force that earth is pulling on me? So I'll let you think about that for a little bit. Well, Newton's third law tells us that if the earth is pulling on me with a force of 700 newtons towards the center of mass of earth, then I too am pulling on the earth with a force of 700 newtons, but in the opposite direction. So if this is me and I'm getting pulled down with a force of 700 newtons, then I too am pulling the earth towards my center of mass with a force of 700 newtons, but in the opposite direction. So earth is pulling downward on me and I'm pulling, I guess you could say, upward on the earth, or towards me. The earth is pulling me towards it and I am pulling the earth towards me. And so if I were to draw it here, I'm obviously not going all the way down to the center of the earth here to draw this vector, but I am pulling on the earth with an equal and opposite force of 700 newtons. But this might seem suspicious to you, because you might think of, let's just say that I'm not sitting in Morocco right here. I'm not on the surface of the earth. Let's say that I'm up here and I'm falling towards the earth. And once again, we can say that the earth is pulling on me with a force of 700 newtons. We'll assume that the gravitational field hasn't changed dramatically with this little altitude. We'll assume it roughly constant near the surface of the earth. But I'm falling, and the force that the earth is pulling on me, gravitational force towards its center, is 700 newtons. And I'm saying, wait, I'm pulling with an equal force on the earth of 700 newtons? How can this be? It looks like I am accelerating much more than the earth is accelerating. How does all of this make sense? And I'll let you think about that for a second. The important thing to realize here is just because the forces have the same magnitude, but they're acting in different directions, it doesn't mean that the acceleration has to have the same magnitude. Remember, Newton's second law tells us that force is equal to mass times acceleration. Mass times acceleration. And for my situation, both for the force that earth is pulling on me and the force that I'm pulling on earth, it might be the same. But remember, earth has a huge mass. So earth has huge m, while I have a much smaller m. So if earth has a huge m, so for a given f, you're going to have very tiny acceleration. For the same f, if you have a more Sal-sized or Sal-massed m, then you're going to have a much larger acceleration. So even though the forces acting on the bodies have the same magnitude, they're going in opposite directions, the actual accelerations can be very different because the two objects have very different masses.